Okay, let's clear up two things, or three things, or four things, or whatever. Okay, so I have taught you 1, 1, 1, 2, and 1, 3. Okay, those are the three I taught you. Today we'll do 1, 4. On the calendar, it was 1, 2, 1, 3, and then 1, 3, 1, 4. They didn't know if they were going to. I didn't know if I was going to be able to do 3 with 2 or 3 with 4. Let me rephrase that. I knew I was going to be able to do 3 with 2. The other teachers weren't too sure. So they're doing 3 with 4. Whatever. So I've taught you those two, and you really officially have 2 assignments. Okay? So I gave you this one, and I thought it was 1.1. It wasn't. It was actually 1.2. You actually happen to know how to do all of it already. So what we're going to do to clean up things, okay, what we're going to do is on Google Classroom, again, don't do any of this stuff now, and you don't have to do anything until Monday. Monday's when I want all this stuff done, okay? Just to kind of, if it's not, I mean, I'm not going to, that's when I want it done. So on Google Classroom, I'm not going to look at, I looked at it because I sent some of you guys like, hey, good job, or appreciate you, or hey, can you do this for me? I sent that because I actually looked at this 1.1 change in tandem. That's where some of you guys uploaded this, okay? So I'm not using that for any grade. This good, because I'm fixed. This was a me mistake, so you guys are having to fix my mistake. Then I put 1.1, so I also put another Friday, the real 1.1 with the exclamation mark, okay? So when you get this 1.1 done, upload it there. Upload the real 1.1 there, okay? And again, you don't have to have it done anytime until Monday. I would like it done by Monday, okay? And then this 1.2, which is this is 1.2, upload all of it at Monday. Okay, upload all of it. Even though I know some of you uploaded part of it here, just go ahead and just upload all of it here. Okay, and that way I'll keep it, because I have to keep consistent with the other teachers on what they're grading. And so if I do a part here and a part here, then we're ahead of the other classes points wise. Y'all follow what I'm saying on that? Okay, so this is 1.1. It kind of has the dark thing at the top. Okay, has a dark thing at the top. These are only 2 that I've given you for homework so far. Okay. So it has a dark thing at the top, and then the big heavy packet, which was mostly multiple choice, right? Upload all of it on Monday, okay? And then when I get done with today's lesson, you'll see 1.3 and you'll see 1.4. And so I'll put 1.3. I guess I could put 1.3 with Monday, but I didn't give you that till today, so I'll actually just put it in as today's. Okay, so I'm going to give you 1.3 and 1.4 today. You already know how to do 1.3. I'm just going to give you 1.4 and add it to it. And so you will have, by Monday, the goal for you guys is to have all 4 of those uploaded. The goal by Monday, because Friday's a B-day again. So from Wednesday to Monday, you should have all 4 of them done. Okay? Don't forget that I gave you the, what was that thing called? Some of you, I didn't even give it to you, I don't think, did I? I may have gave it to everybody. The big, real heavy packet with 87 questions that you're doing. Yeah, practice skills that you're doing. That's due, right? I don't care if you do or not. You just need to make sure you know how to do all of that. I'm assuming you know how to do everything in there. And so again, look through it. If you don't know how to do something, you need to get with me and we need to figure it out. Because when we get to it in the classroom, I'm going to assume you know how to do it. Okay? All right. Is that clear as clear? I try to write that down in the stream and send to you guys. And I probably should have run it through a AI to clean it up and make sure it's understandable, but I figured, we'll just do it today. We got plenty of time, so we all have a learning curve on all this stuff, so we're good. Okay? Everybody okay? Any questions? Some of you guys have sent some comments to me through Google Classroom. That's perfectly fine. Can you see this? I forgot. It may be out of order. Yada, yada, yada. That's great. Just keep doing that kind of stuff, and I'll try to reply to them. Actually, I try to hit it pretty quickly. It depends if I have my computer and my phone. My phone's not as easy to reply to that, but I try to do what I can. And I may just send you a separate email. The best way to contact me nowadays is email. And so I get a notification through my phone, and I'm on my computer a lot. Just the best way. If you ever got any questions about anything, send me an email. Okay? Or if you have it about that specific assignment, just add it to the comments on that assignment. Either way. Okay? Because those all come through on email. All right. I don't want there ever to be confusion on your part. And I have a bad habit of assuming a lot of things. Also, I did post answers. So if you go back, a lot of times you may have to go back, but like, there's the YouTube, there's the worksheets, there's the notes completed. Where did I put the answers? I must have put them down here. Uh-oh, I don't want you to move. Ah! Did I not put them? Okay, here's the 1.1 answers. I know I put those. I see those. I'll put the prerequisite skills answers. I thought I put them. You asked me about that. I told you I put them. Did I not put them? Oh, you should have said something like, you may have thought you did. She sent me an email. She said, will you post the answers, please? I said, I did. They're there. She should have said, no, you idiot, they are not. I've looked 4 times. They are not there. And I would have said, they're right there. And then I would have looked and said, my fault. They're not there. I got them. I didn't post them. Idiot. That happens a lot. Just let me know. And when I tell you they're there and they're not there, you need to let me know. No, they're not. I'm probably a little bit different than a lot of your other teachers. I don't know. I expect you to be respectful, but yet we also have a lot of fun. And if you need to say something, say it. And just, I've looked 3 times and they are not there. Not, I'm sorry, sir, but I really believe that they aren't. I've looked 4 times, they ain't there. Okay. Y'all okay with all that stuff, right? I mean, I know you're supposed to be professional, and I love this thing. I forget how, I remember. That's how I get out of it. No. There you go. Okay. So that's our plan. Get those 4 done. 1.1, 1.2, the big packet 1.2. You've uploaded part of it. Just upload all of it to 1.2. And then I'm going to give you 1.3 and 1.4 today. We're going to discuss 1.4 today. I want to fix that last part of 1.3. I didn't do a good job on that. I still don't like it. So I want to fix that part. I forgot where I put it. Oh, I remember. So let's see where I did that here. That was 1.3 notes completed. Let me open that real quickly. There's my hieroglyphics. Okay. This, example 4, let me kind of fix that real quickly, okay? I went back and thought about it, and I don't like this. Because I'll be honest with you, even though that's 1 and that's 1.1, I don't really know officially what this function does between 1 and 1.1. Even though that's 4 and that's 1, I mean, it's possible to do something stupid between here and here. There's not a whole lot of room, but it's possible. So I don't like this, okay? But let's see how I can fix this. You may have to just watch. I know how I can fix it. Okay, so I told you all three of those were concave up, and I lied. So that's why I really got to fix it. Okay, I rushed through it. We're going to assume that nothing stupid happens between here and here and here and here and here and here. Okay, we're going to go ahead and assume that. I don't like that though. There we go. Okay, now I'm going to go here. And then I'm going to go, you're supposed to pop back up. There you are. You're going to go here. I'm going to go here. I don't want that anyway. And then it's going to go here. So fast. Thank you. I should have prepped this, sorry. I don't want square, I want rectangle. Rectangle. What are you doing? It's been a long time since I've touched this thing. Rectangle. Okay, here's how I'm going to fix this. This one is concave up here, okay? Between here and here, I'm going to look at this two different ways, right? So between here and here, that's 3. Between here and here, that's 1, 0, that's 2. Is that right? And between here and here, that's 1. Okay with that? And so between here and here is constant. Between here and here, so this is 0.1, this is 0.1, and this is 0.1. So this is 0.1, 0.1, 0.1. So 3 over 1, 2 over 1, 1 over 1. It's consistently getting, or it's consistently somewhat getting smaller, if you will, but it's a constant. And if I look at it like I said I was with this 1 and 4, we're good because 1.1, so that's like 2. You can change up the scale. So 1.1 is here, which is at 1, and here's 1.2, which is at -1, and here's 1.3, which is -2. And you can easily see how that's concave up, which is increasing because it's constant, okay? So I didn't mess up there, I did good there. Here I did bad. Because between here and here, it's 3. Between here and here, it's 3, and between here and here, it's 3. So that's what type of slope? Linear, it's constant, right? And if it's constant, then it's neither concave up nor concave down. Y'all okay? So when I plotted those points, I didn't plot them very good. I'm okay still doing it the way I tried to. I just did a horrible job of it. So this is my first mistake this year. Y'all, I only make one mistake a year. So I'm done. This is it. Now, sometimes I start my years over. Sometimes I start them over. Like last year, I made a whole lot of mistakes. But this year, I've made one mistake. So if I make one today, then we'll start over then. I only make one mistake a year. So 1, 1, right? And if I go to, so again, I'll put 2 out there. 1.1 is 4. 1 point is 7. So y'all can see that that's linear. Okay, so I did a horrible job of that. And again, you can see it because of the differences. Because if I put 3 over 0.1 and 3 over 0.1 and 3 over 0.1, then that's just a constant slope. So it's neither concave up nor concave down. Okay, and then here I got 3, and then here I got 4, and then here I only got 2. That's neither. Because this is not constant. This is 6. Gosh dang, my year just started over. Now I got a new year. Now I've made one mistake this year. 6, 4, 2. So the difference here is 2. The difference here is 2. Is that right? Did I do it right? 7, 8, 9, 10, 11, 11, yeah. 6 over 1, 4 over 1, 2 over 1. 1, 1. 1.17, 2, 3, 4, 5, 6, 7. Linear right now. 1.211, 7, 8, 9, 10, 11. 1.3. Why is that not concave up? Oh, well, I don't know. Hit me. Talk to me. Say again? Rate of change. But it's getting smaller over there.
No, because that's negative.
Oh. Stupid negatives. Y'all good? I don't like these at all. I really don't. Because again, I really don't know what happens between here and here. I really don't. So we could do something really crazy and not even make this thing a polynomial. I could have a gap. I could have a hole. It may not even be a function. So I don't like these table things on that. I think we're just assuming that it stays constant. I don't think it said that in the rules. Okay, so we're going to go with that. Y'all clear as mud? Exit. No, I don't want to save that. Okay, now let's get out of that. Let's go to, here we go, 1.4. Polynomials. Polynomials. So we've gone a little bit linear. We've looked at a little bit of quadratics. We've looked at some polynomials in some graphs. But now we're going to talk about polynomials. I hope, well, I don't hope. I know if you were here at Bentonville, you know pretty much everything you need to know about polynomials. You know about the end behavior of polynomials. You know that they turn so many times. Linear is a polynomial. It's just a special polynomial. Quadratic is a polynomial. It's just a special polynomial. Cubic, quartic, right? Polynomials, anything with some type of variable and some exponent. I guess a constant is a polynomial. It's just a really special polynomial. Okay? So exponential is not a polynomial. Exponentials are not polynomials because they have asymptotes. Rationals are not polynomials because they have asymptotes. Polynomials start at some place. A lot of times you guys are used to starting them at negative infinity, and then they end someplace, and that's typically positive infinity. In pre-cal, we don't start them at infinity and infinity a whole lot as much as we actually start them at endpoints. Okay, just kind of recognize all that stuff. Polynomials, okay? Again, I don't assume you know that. I know you know it. You just have to remember all that stuff. Here's polynomials. Probably they showed you this exact same thing in Algebra 2. They typically talk about this value right here being a sub n. And then they put x, or they could put any variable they want to, but they typically put x. If this is p of x, then it's going to be x's. If it's f of x, it's going to be x's. If it's going to be f of h, then it's going to be h's. If it's f of t, it's going to be t's. If it's going to be p of t, it's going to be t's. Okay, so whatever that variable is, and then it has some kind of an exponent, right? And then all they're doing right here is saying a sub n minus 1. Basically, they're just telling me it's a different coefficient, or it's a different constant, or it's a different whole number, or I shouldn't even say whole number. It's a different, I can't say integer. It's a different real number. Because it could be a fraction, could be a decimal, could be all kinds of things. And then this x says n minus 1. So whatever this n is, it drops down 1, and it drops down 1, and it drops down 1 until we get to no variables anymore at all, right? Again, all that stuff saying that. The leading term of this one, the leading term is the a sub n x to the n. That's the leading term, okay? Typically, it's the very first term. Typically, it's the very first term. Now, they're going to try to trick you in one of these examples, okay? I don't want to say it's the very first term always, because it's the term with the highest exponent. That's the leading term. Just sometimes they don't put them in order. They try to trick you. The degree is whatever the highest exponent is. In this particular case, it's n, but the degree is the highest exponent there you see. The highest exponent you see. If you don't see one, then the degree is 0. And then the leading coefficient is the coefficient that goes with that degree. It's the coefficient that goes with that degree. In this particular example here, it's the a sub n, right? But again, it's the one with the biggest coefficient. I'm sorry, the biggest degree, the biggest exponent. Not the biggest coefficient, the biggest exponent, okay? And so here I have example number 1, and they're going to go through 3 of these really quickly. And so I'm going to ask for the leading coefficient, and I'm going to ask for the degree. I like to do the degree first because the degree really determines the leading coefficient. The leading coefficient, you don't really need to know it. You need to know the degree first. So I go with the degree first, which is pretty easy because this is a degree of 0, this is the degree of 1, and this is a degree of 4. Right? You can't have negative exponents. If you have negative exponents, it's no longer a polynomial. Right? All the exponents have to be positive and they have to be integers. They cannot be fractions. They cannot be fractions, they cannot be decimals, they cannot be negatives. As soon as they're that, it's no longer a polynomial. And so if that's the degree, then the leading coefficient is the coefficient that's in front of that variable, right? Again, all this stuff should be pretty easy. This is the one they're going to try to trick you with. They put the degree of 1 first and then the degree of 3. So the degree is 3. Be careful. I'm telling you right now on the test, we're going to not put 1 in order. I'll tell you right now, you're going to see one that's not in order. So, and then the leading coefficient is a -7. If there's a negative in front of it, the negative goes with it. I treat every number as either positive, negative. I don't do a whole lot of pluses and minuses. I basically say this is 12x's and I'm adding -7x's. So that's a -7x cubed and then a positive 11. This is a positive 3 and a positive 2 and a -7. Here, the leading coefficient, the degree is 0. There's no variable. There's 1 there. We're just lazy as mathematicians, guys. We're lazy. We don't like to put x to the 0 because you guys know anything to the 0 power is 1. And so there's an x to the 0 there. We just don't like to put it because we're lazy. So the degree is 0, but the leading coefficient is 4 because it still goes with that. It's the only coefficient, so it's 4. Okay? All right. Again, all this stuff you should know. That's not a big deal. The extrema of a graph are the minimums and maximums. So this is a new word for you guys, extrema. Extrema, okay? Extrema. Those are minimum and maximums of functions. There are, I guess there's 2 types of extrema. There's 2 types. Relative or local. Relative or local, and then absolute or global. I don't use global very much, and I don't think I use local. I'm not sure I use this. Okay. So, polynomials. Polynomials have relative maximums or relative minimums. I think I said that backwards, relative minimums and relative maximums, where basically it changes from increasing to decreasing. It's bottoms and tops, right? So this is different to you guys. If this had an arrow on it, it's nothing because it's going forever. But this doesn't have an arrow, it has a dot. So because that has a dot, it could be, let me rephrase that, it's a minimum. Why did I turn that off? Let's turn it to red. Okay, so there's a minimum, here's a maximum, here's a minimum, here's a maximum, and here's a, oh, that one has an arrow. That one has an arrow, so I can't talk about that one. Y'all okay with that? So this is an endpoint. You have to include endpoints. There's no endpoint on that side over there. It's going to infinities. So this is an endpoint, there's a max, here's a min, and there's a max. Okay? And they want to know what local minimums are. So, local minimums, -4. We always talk about the x values. Don't talk about, well, cuss, I'm sorry. Local at x equals -4. And the minimum is -3. I like to put the point. I like to put -4, -3. He didn't. So we're going to go along with what he did right now. But local minimums at -3. Local, whoops. cuss. My year just started again. I need to go back to bed. Local minimums. X equals, let's get rid of that 3 because it ain't a 3. It's like I thought it was. It's -4. That's where the minimum is. There's one at -2. Nope, cuss, that's a max. I did that on purpose. Y'all okay there? -2. At 0, that's a minimum. At 3, that's a maximum. And that's where we stop. Hit me.
So if we don't know where to write the graph, just ignore that one?
I have to ignore it because we don't know what happens. It may turn again. It may. Doesn't look like, and typically doesn't when you put arrows on it. But if you don't put an arrow on it, guess what? There's no minimum. It's going to keep on going. Okay with that? So all of these are local minimums or maximums. Global maximum or minimums or absolute maxes or minimums is the greatest it could possibly be or the smallest it could possibly be. Okay? That's the global. In other words, this is not a global because there's a number higher than that. This one, that is an absolute max. That is an absolute max at 3. It's at 3. And then this one does not have an absolute min because of the arrow. If that was a point, then it would have an absolute min here. But it's not a point, it's an arrow, so it doesn't have an absolute min. Everybody okay? Absolute maxes and mins and relatives. All of them are relative. All of them are relative. They don't have to be absolute. Okay? They don't have to be absolute. So in this particular case, they're going to go ahead and tell me. Absolute max at 2 when x equals 3. Okay? Absolute max equals 2. Y'all see that, right? Equals 2 at x equals 3. And there's not one. There's not a min. There's not a global or an absolute. Again, I just said I won't use global, but there's not an absolute minimum because of the arrow. If that didn't have an arrow, then that one would be an absolute min. If that was a point, then that one would be an absolute min. Y'all okay with all that stuff? So extrema. Very, very, very important in mathematics. It's very important in mathematics. Example 2. Find and classify each type of extrema. Or write NA. What type of polynomial is that one? Start with a Q. Quadratic. Y'all okay? Sorry, I know I ask arbitrary type things. Both of them have arrows. Both of them are arrows. Okay. Relative minimum. There ain't one. They ain't one. Because of arrows. There ain't one. Relative maximum at x equals 1. Absolute minimum. Ain't one. If there's not a relative minimum, there can't be an absolute minimum. So not available. Nope, there ain't one. And the absolute maximum is at 3 when x equals 1. Any questions about that? Absolute, relatives. Easy peasy, lemon squeezy. Here we have a polynomial that starts high, goes low, goes high, and then we have a infinity. Okay? Domain goes from -4 to infinity. Range looks like it goes from -infinity to 2. Oh yeah, I kind of remember that stuff. Relative minimum. -2. That's it. Relative maximum, careful, don't forget the end point because of the decimal. At -4. There's also one at 3. We just have to get close on that. I mean, if it's 2, if you put 2.9, I guess you're okay, but typically those are integer values. All right. Absolute minimum Name one. Because the arrow, we don't have an absolute. It goes to infinity, and infinity's and it doesn't make anything. So there's not one. Absolute max. I think that one's taller than this one. So it's at 2 when x equals 3. Hit me.
How do we know
How do we know that
that's not the absolute minimum?
what's not the absolute minimum?
That's very simple.
Because of this arrow.
Couldn't it change?
It could. That's what I mean. We don't know. So as of now, we don't know. It's NA because we don't know it. Fair enough? Great question. Great question. Y'all follow what he asked, right? I mean, we don't know that this thing may go down and then curve back up. Typically with arrows, it doesn't, but we don't know that because I don't have the function. I don't know what it looks like. I don't know what the degree is. I don't know anything else about it. So we're just going to go with what we can see. Oh, this one's got a dot and a dot. So this one's bounded. Minimum -3. Minimum 3. Relative max -4. 0 and 5. Could have done like big time teacher stuff here and changed some colors. Yeah, there we go. Absolute minimum happens at -3 and -3. Green. -3, -3. And absolute max happens at 5 or 4 or 5. Any questions about absolute, relatives? Easy peasy, lemon squeezy. Good? In calculus, they give you the equation and you have to find those. And what's special about it, it's where the slope is 0. Right? Because the slope is 0 right here. The slope is 0 right here. Fun facts about polynomials. Between two real zeros, there must be at least one I know what this is, but you guys help me figure it out. So you got a function. You got a 0 and a 0. Between those zeros, there has to be a max or a min. And it has to be relative. We don't know if it's absolute. Because the only way to get from here to here is I've got to turn back down. Or turn back up. I got to be going down and turn back up, or I got to be going up and have to turn back down. So there has to be between two real zeros, there has to be at least one relative max or a relative min. Polynomials of blank degree must have a, so I'll just give you a slight little hint here. They're going to ask you if it's an even degree. What do you know about the end behaviors of even degrees? They're going the same way, right? And if they're going the same way, if they're both going up, it has to have an absolute minimum or an absolute max. If it's going down, down, it has to have an absolute min or an absolute max. Depends on which way it's going. Homeworks, I'm okay with you abbreviating ABS min, ABS max. Test, you probably want to make sure that you know exactly what you're talking about. All right, one more thing we need to talk about in 1.4, and they're going to call it a point of inflection. Point of inflection. And that's where the graph will change concavity. It will change concavity. What I mean by a point of inflection occurs when a function changes from concave up to concave down, or from concave down to concave up. At a point of inflection, the rate of change changes from increasing to decreasing, or from decreasing to increasing, because you're changing concavity. Concavity up is increasing, concavity down is decreasing. So it has to change the rate of change. Holy cow. Up, 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 up. I'm changing. And we kind of have to guess where we're changing. So we're up, down. Okay? Down, 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 down. I think it's there. Down, up. Okay? Up, 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 up. Y'all okay with that? So this is called a point of inflection, and this is called a point of inflection, because that's where it's changing concavity. That's different than a max or a min, right? This is a min, this is a min, and this is a max. I'm guessing there's, I don't know, I forget. I think if they're both there, that's the absolute min. The absolute min is at -2, and it happens at -2 and also at 2. I think you have to list them both. I need to find that out, but I'm pretty sure. It's been a long time since I did calculus. The graph of G is shown in the figure above. Use the graph to answer the following questions. Find any values of X where G has a point of inflection. So G has a point of inflection at, we already said this, -1 and 1. X equals -1 and X equals 1. I should not see this on your test. Okay, I shouldn't see that on your test, because that almost looks like a point. X equals -1 and X equals 1. I don't really like X equals -1, comma 1. Again, all that stuff's okay for your homework, so you want to be precise on your tests. For each of the following intervals, determine if the rate of change is increasing, decreasing. Explain your reasoning for each one. So from 3 to 4. I need to do some erasing. I got some crazy stuff going on up here. So from 3 to 4. 3 to 4. 3 to 4. The rate of change is increasing because we are concave up. It's starting off at this kind of a slope, and it's getting steeper. If you wanted to explain that, right? You're starting off at a somewhat positive slope, and it's getting steeper. That really explains it. So concave up explains it, but it's starting off at a certain slope, and it's getting steeper. Again, just draw your tangents if that helps you, right? Sometimes seeing it with your tangents help. That pencil's doing my tangents. That's where it's 0. Now we're negative. And at some point we become less. Okay, so you can draw your tangents along each one of those. -4 to -3. -4 to -3. -4 to -3. Concave up. Increasing there. Good? Yes? Okay. Y'all know I make mistakes. -1 to 1. Concave down, decreasing. It's starting off positive. Starting off positive. I'm getting to 0. And then I'm going to negative. So I'm starting off positive. I go to 0. So it has to be decreasing. I'm starting off at a positive slope. Then I'm going to a negative slope. Positive is bigger than negative. It has to be decreasing. And you can state that. You don't have to state concave down. You can say you're starting off at a positive slope, going to 0, and then going to a negative slope. That explains it. That might explain it a little bit more than saying concave down. And then from 1 to 2. 1 to 2. 1 to 2. Concave up, increasing. It starts off at a negative slope and becomes less negative. So less negative means it increases because you're getting closer to 0. Closer to 0 from negatives makes it bigger. Y'all see that? Yeah, calculator? So when you see that, you're expected to use a calculator. You can use Desmos. You can use your calculator, whatever you want to do. Let me show calculator. Just make yourself feel comfortable that you know how to do this because you need to know how to work around your calculator. Okay? I feel like I need to teach both. All right. Calculators do a lot of things. They do a lot of the good things for you. They'll do a lot of math for us, and they'll do a lot of math when it becomes really difficult math, right? And so we have a whole lot of buttons on here, and we're going to use a lot of these buttons this year. One of these buttons, these all have to do with my graphs. Not only do they deal with graphs, but they deal with equations. And so when you hit your y equals, for the love of goodness, please make sure none of those things are highlighted. Because if one of those 3 things is highlighted, it's going to mess up your calculator always. And so get good at recognizing that those things are highlighted or not highlighted, because we're going to turn them on and we're going to turn them off this year, right? So anytime we're dealing with equations, I make sure all 3 of those things are off, okay? Those are off. And then we're just going to plug and chug whatever that equation says, okay? And so picture this, right? You can use Desmos on the test, or you can use your calculator. But if you click the Desmos button, it typically hides your screen. And so now you may not be able to see your equation. So now you have to take your equation and write it on paper. And if you've got a chance of messing up doing that, transpositions, just kind of recognize all this stuff. Some of you may do that better. And it may not, you might be able to change some windows around where it doesn't hide it. Just kind of understand the situation that you might be in when you have the pressure of a test, okay? So with your calculator, you don't have to worry about that. The only thing you have to worry about is hitting the wrong button. Somebody tell me what that equation is. Does it start off with a negative? 1.37t. I don't have a t. I got an x. 2, 5. Y'all okay? Hold on. Y'all good with that? Everything? Don't put the minus sign. Don't put the minus sign. That's going to, well, you can put it here, but I heard him say plus. So don't put a minus sign right here. You get an error. Okay? And you actually do have a T. There's a T right here. It just, when you hit it, T doesn't come up. T comes up if you do something else. So we don't care. All we deal with is X. You said that was a plus. Everybody okay? All right? Now, plug in and chug in. What was the next one?
4.218. X to the 4. Minus 0.357.
Now you hit the minus, don't hit the negative. 0.357? 0.357.
X to the 2nd.
So you can just hit second here, or if you want to hit exponent 2.
Plus 3.
Okay, any questions? Notice how this thing's lit up. That means it's going to graph it. If you go up here, you can go over and you can hit enter, and now it won't graph it. That graphs it. Mine's color. Most of you guys are color now, so it's actually going to graph it in blue. If you don't want to do blue, move over there and change the color. You can also change a couple other things, right? There's the color, and you can change it to a line. If you don't want a line and you want to do something different, you can make it a greater than, or you can make it a less than. That starts shading in stuff. You can make it a So a line with a circle, you can make it a circle that puts just a bunch of points. You can make it a dotted line. Most of this stuff you don't do, and then you got a small dotted line. I don't know, right? Just recognize that these things happen because we're going to change some of that stuff this year. Okay. Okay, we're good? Now, a lot of times we'll hit graph, and there's no telling what my windows, we're going to change our windows a ton. I don't see it, my calculator's broke. No, I just got a jacked up window. Oh, there it is, part of it. Showed up. That's because our windows are jacked up. Windows get jacked up. It happens. You're going to want to jack up your windows. So I typically always hit zoom 6. That's the standard. That does the 10, 10, 10, 10. That does the 10, 10, 10, 10. So I typically do zoom standard, and now it looks like it should. Now, we got an issue. I can see this extrema. I can see this minimum. But there's a maximum up here I can't see. How do I know it's a maximum? Well, because it's going uphill and it's going downhill. If it goes uphill and it goes downhill, there has to be a maximum there. There may be something else. Remember that this is a 5th degree polynomial. So it could have 4 terms in it. We should know that stuff from polynomials. Polynomials could have the degree minus 1 terms. Could. So because I can't see that bad boy, I need to change my window. So I'm going to hit window, and I'm going to change. I don't really care about my x min and my x max right now, but I need to change my y max to be something other than 10 because I can't see it. And so I might do 20, I might do 100, I might do 2,000. Who knows? My guess is it's not going to be a really big number because my coefficients weren't that big, but I might just try 20. You don't want to make it so bad, but then I'm going to do 20. Let's see what happens if I can see it now. No, I still can't see it. I probably should have gone a little bit bigger. So we'll go back to window, and we're going my Y max, and let's go 50. It really doesn't matter. I just got to be able to see the darn thing. I got to be able to see it. And if you want to help your graph a little bit more, I may change my X to be like -5 and +5. Window, -5, +5. The next button's telling you what those tick marks are going by. They're going by 1s. Because if I put 2,000 up here, then you're going to just see a whole bunch of, it's going to be so close, it's going to be, you know, follow what I'm saying? So that's all the tick marks. Don't ever change the res, and don't ever change that, and don't ever change that. Just graph it. And so now it looks just a little bit better. But you can change your window just like you can change your window. You can draw different graphs. You can go by 1s, you can go by 2s, you can go by 8s, you can do all kinds of things, right? But your job is to make sure that I can see these turns, whatever you got to do. And remember, I told you you could see 4 turns. And so I like to zoom in a little bit better just to make sure I don't have something small happening right in here. I make sure I don't have a small something, okay? And the closer you can zoom in, the better off you're going to be. In fact, if I go from -1 to 1, just to show us real quick, just to make sure, -1, 1, you're going down there, okay? It's only going to graph that little part right there, and it looks like it goes straight across. So it looks like it's just a curve, okay? Talk to me. It isn't?
Yeah.
It does change,
So
huh?
if you click trace on your thing,
I don't,
along the line,
don't hit trace.
um,
It's okay though. It does go up and down, right? And so then we can also look at that, right? We can look at the table, and so there is a little sneaky in there. And so we're getting ready to find it, okay? We're getting ready to find that. So it's gonna ask, what does the question ask? What is the minimum, what is the maximum, or where's it gonna change from increasing to decreasing? So decreasing, and 2 little sneaky people already told me that it does actually change in there, okay? So here's what you do now. We're going to do some work on this graph. Second, scatter plot, table set, format, calc. Table. I want to calculate some things. Don't use trace. Trace estimates. Don't use trace. Trace estimates. You can use it and see what it does. You can see that it goes up and it comes back down. But don't use it to find any answers. You will be wrong. Okay? You will be wrong. You can calculate any value you want. You can calculate any zero you want. That's where it crosses the x-axis. You can calculate any minimum. You can calculate any maximum. You can count any intersection. We don't have an intersection because we only have one graph. This will find the derivative, which is calculus, and this will find the integral, which is calculus, so we won't be using these things. Now, this stupid calculator here, you have to tell it, where do you want your left bound to be? The other calculator I have, you just have to hit minimum and it finds all of them. And Desmos will do that. Desmos will just find the minimums. You don't have to set a bound. And so that's advantageous to you because it finds them really quickly. All you got to do is move left and right. This you can't. Okay? So I've got to put this little cursor somewhere over here. Somewhere over here. And now we got to do some big time messing. And then I'm going to hit enter. Notice that it puts me a line, my left bound, because it's going to find the minimum between wherever I tell it to. Where does it do that other turn at? Do you have any idea? You have an about?
There to zero. It's between that and zero.
Between that and zero is the minimum? That's where I was going to go with it. So now look what it's asking me for the right bound. So I was going to put this thing at 0. Now you can do one of two things. You can move it to 0 or type 0. And when I hit enter, that puts my right bound. And you can kind of see it here and here. Now it wants me to guess, and I don't have to guess. If I just hit enter, it tells me there's a minimum right there. It tells me the x value, and it tells me the y value, which is kind of interesting because it doesn't look like there's a minimum here and here. If it was just one turn, that minimum should be somewhere around 0. Okay? So my guess is I have another maximum somewhere, because I'm guessing it does that. It's so small you can't see it. Okay? And so we'll go second, calc max 4. And I'm just going to go from there somewhere over here. Oh, I was right on it. Gosh, I probably missed it. Y'all see, y'all? So when you do that, you make a closed bound. Like you made, instead of an arrow, now you made a dot. So let me do that again. Mode, second, calculate, max, 4. Let's put the left bound at negative point. Was that 5 and 5 or 1 and 1? What'd I do? I did 1 and 1, didn't I? So let's do point 5. And let's do a max at 0.5. Dang, I still got it. I need to make it bigger. Y'all see the frustration with this stupid calculator. Max, negative 0.5, 0.9. I still got it. Guess there's not one.
It goes back down afterwards.
So where's it at? How do I know this? Can I zoom in? Zoom in. See, it doesn't do it. Stupid calculators. Say again? Zoom out. Is that going to work? Oh, it curves down after that? Y'all see the issues with this, right? I love these calculators. If I need to change that from... Yeah, I realize that. Yeah, so that's why Desmos works a whole lot better. Go with me on that too.
So you're basically like it's 0.2 and then 0 and then 0.2 again about.
Where was the other one at? Like 6? I forgot. This one's easy to find. Good. Second, calc, max, 4. Let's put it at left bound at 0 and right bound at 8. Beautiful. That's easy. Hit me.
How many decimals are ROC?
3. 3, 3, 3, 3. Good question. Always 3. And they don't care. Let me write this so you guys can see it. Where am I back? Let's go back to this. They don't care if it's negative 4.3812. They don't care if you do negative 4.31 or 381. Well, you can't do that. Or if this was a 5, they don't care if you do negative 4.381, or they don't care if you do negative 4.382. But they care if you just do negative 4.38. You got to go 3. You can go more. You got to go 3. Yep.
If it were a 6, would they care?
Yeah, they wouldn't care. Yeah, they don't care that you round this or not. It just better be the right number. You can't make that number up. And that's why I'm going to tell you also, whenever you're doing any type, don't round to the end. Don't round to the end. That'll come up a couple times. When you're trying to substitute values in and things, we'll do that one word. That's a good question though.